This video is going to cover factoring, specifically special patterns. So we're going to be looking at factoring the difference or sum of squares. And we will also look at factoring the difference or sum of cubes as well. But we're going to get started with the squares. Now, first of all, the general pattern looks like this. If we have something that looks like a squared minus b squared, we can factor that into two binomial factors. So the first binomial factor will be a minus b, and the second is going to be a plus b. When we multiply it, we will get a squared minus b squared. If you see something like a squared plus b squared, which is the sum of squares, this is considered to be not factorable or prime. Let's take a look at a couple different examples. So, start with the first one, x squared minus 9. So we can clearly see that we have an x squared term, we have subtraction, which is difference, and we have 9, which is also a perfect square. So when I factor this, I'm going to take the square root of x squared, which will be x, and the square root of 9, which will be 3. And in both of my binomials are going to have that x and that 3 in place. One binomial will have a minus, the second binomial will have a plus, and that's it. So let's take a look at a second example. How about, undecided. All right, 36x squared minus y squared. So even though this one is a little bit more complicated, it works the same way. We still have a perfect square of 36, a perfect square of x squared, a perfect square of y squared, and then subtraction in the middle. So I need to think about what is the square root of 36 and what's the square root of y squared, and that's going to be 6x. The square root of y squared is going to be just y. So both my binomials are going to have a 6x and a y. One's going to be a minus, the other one's going to be a plus. It doesn't matter if you have the plus and the minus in the reverse order, it's still going to give you the same product. So I'm going to rewrite this guy as a plus, and this guy as a minus, and it's still going to be a correct answer. Alright, let's consider another example. X squared plus 25. Now if we look at this one has a sum. So even though we have a perfect square and another perfect square, because it has this addition, this is not factorable, we're going to call this prime. Okay, so prime and not factorable mean exactly the same thing. Alright, so one more example with the difference of squares. 2x squared minus 50. Now you might be asking yourself, why did I include this example? Because 2 is not a perfect square and 50 is not a perfect square, and you'd be correct in that statement. What we're going to do here first is actually factor out the GCF. So after I pull out the 2, or factor out the 2, what I have left over is an x squared minus 25. Now we have something that is a difference of two perfect squares. So we're going to factor what we have on the inside. So that's going to give us an x minus 5 and an x plus 5. Alright, so now we're going to look at a second special pattern. The next one is going to be the sum or difference of cubes. So here's what the pattern looks like. A cubed plus b cubed, and when we factor it, we're going to get a plus b for the first binomial term. The trinomial factor is going to look like this. A squared minus ab plus b squared. Now, the difference of cubes is very similar. Our first binomial is going to be a minus b, and then the trinomial factor is going to be a squared plus ab plus b squared. Now, I can easily understand that looking at these two factors, it can be a little overwhelming. It looks a little complicated. but there is a straightforward mnemonic device, sorry, it's a word I can never say, at least correctly the first time, mnemonic device that can help us remember how to factor this trinomial, and that is going to be SOPs. Okay, so the first S stands for square. The O is going to be opposite, and the reason why we call this the opposite is because the sign that we have here and the sign that we have here are always going to be opposite in sign. The first P is going to be product. So product meaning multiplication. We're multiplying this A and this B to get the product AB. The second P is going to be plus, and if you put a positive in there, that makes sense as well, but I like to remind myself plus. So I'm doing A squared plus AB plus B squared. And this B squared, hopefully you can guess that the second S is going to be standing for square. Okay, now one thing I'm going to point out right now, because I think this kind of is helpful, oftentimes these two guys right here, this O and this P, I kind of put them together and say opposite product instead of thinking them as two separate ideas. It helps to remind me that even if I looked at this product of A and negative B, I want the opposite product, the positive AB. All right, so let's take a look at an example before we move on. All right, so the first one we're going to consider is x cubed minus 125. So to get started, we're going to look at the binomial. Now the binomial is going to be the cubed root of what we have here, which is x, and the cubed root of what we have here, which will be a 5, because 5 times 5 times 5 is 125. Because we have a minus sign here, we're going to have a minus sign inside the binomial. Now we're going to use SOPs to help us factor the trinomial. So I'm going to write SOPs above. Okay, so the first S stands for square. So I'm going to square this x, and that's going to give me x squared. So like I said before, I'm going to put these two guys together, opposite product. So I have inside this binomial here an x and a negative 5. I'm going to multiply them, and that gives me a negative 5x. But I want the opposite product, so that's going to be a plus 5x. The second P is a plus, and now I want to square the second part, which is the 5, so that's going to be a 25. And then we're done with that first example. So let's take a look at a second example, and that's going to be 27x cubed plus 64y cubed. So already, I'm sure you're looking at this thinking it looks extra complicated, and you're correct, but I do think sometimes looking at a more complicated example actually in the long run will help you better understand what the SOPs is telling you. So for the first parentheses we have here, we want the cubed root of what we have right here. Because it's a 27x cubed, I need two parts to it. I need the number part, which will be the 3, and the variable part, which will be the x. Now I'm going to look at what I have second, and it's a 64y cubed. So I need two parts again. The cubed root of 64 is 4, and the cubed root of y cubed is just a y. So if you're hearing me say cubed root, this is the symbol I'm talking about, cubed root. So if you needed to, you could type this into a calculator. Cubed root of 27 is 3. Cubed root of 64 is 4. For these particular problems, you're always going to get something that works out perfectly, at least if you're asked to factor. All right, so now there is a plus in the middle. Because there's a plus in the middle, we want a plus in this binomial. So now that we have the binomial set, we're ready to factor the trinomial. And again, we're going to use SOPs to help us do this factoring. So the first S is standing for a square. Now I need to square all of this 3x. So I'm not just doing the 3, I'm not just squaring the x, I'm squaring all of it. And when you square a 3x, you're going to have to square both the 3 and the 2. So that's going to give us a 9x squared. Now again, I want the opposite product. So I'm going to be multiplying 3x times 4y. So I'm going to have to multiply the numbers, which will give me 12, and the variables, which in this instance really just puts them together. We just now have 12xy. I want the opposite product, so I'm going to put down a minus 12xy. The second p is plus, and now I'm going to square the second part. So I'm going to square the entirety of 4y. So when I square 4y, again, the square goes to the 4 and it goes to the y. So we're going to have 16y squared. And we're done.